Okay, so in this video we're going to go over chemical bonding. So before you answer any question regarding any topic whatsoever, it's very important that you understand the main topic, what is basically talking about, and that will make your work very simple. Okay, so this is a question from the paper that was 2020. That's paper 2 science, that is school certificate, right? So when talking about chemical bonding or just bonding itself, you're just talking about a process which elements undergo to have a full outermost energy level. Remember to say elements that are on the periodic table, starting from group 1, okay? I would say group 1 to group 7. They don't have a full outermost energy level, unless those that are in group 8 that we call inert gases. Okay, those are we say they are innate because they are unreactive. And why are they unreactive is because they have already attained a full outermost energy level. So what does it mean to have a full outermost energy level? It's just a matter of us knowing how we fill up electrons in the particular shell. Okay, so when, let's say you are given this, say this is the nucleus of an atom. This is the nucleus. So we have the proton and the what, and the neutron. That's, we say this is the first. Say we have a shell there, we have a shell right there. So we have shells that we name using letter N. We can say number 1, N2, N what, 3, N what, 4. So N means the number of shells, so meaning each number of shell has a maximum number of electrons that it can accommodate. So for us to know whether an element, or we say an atom, has a full outermost energy level, is for us to know, let's say if you're talking about N1, this is the first shell. This one we should always keep in mind to say it can accommodate how many electrons? 2 electrons. N2, meaning the second shell, it can accommodate a maximum of how many electrons? 8 electrons. So now the question is, how do we find this? How do we find what we have right there? So there's a simple formula that we can use for us to know the number of shell, the number of elements that we can have in a particular shell. That formula is just basically 2 n to the power what? To the power 2 right there. Okay, so for the first shell we can say 2. What we have our value of as our value of n is what? Is 1. 1 to the power 2 is what? It's going to give us 2 multiplied by the 1, which will still give us what? A 2. Then of course the second shell, we can say 2. We say 2 here, we put our 2 right there. 2 to the power 2 is what? 4. So meaning saying 4 multiplied by 2 giving us what? 8. That's where the 8 is coming from. We can go on and on and on. We can go to the third shell. 3 to the power 2 is what? 9. 9 times 2 is what? 18. So that shows us the number of electrons that the third shell can accommodate, and you can do the same for the other shells that you can have. Alright, so another thing that we need to keep in mind is that okay, when you go to the question that we have right there, you say the question was B7. We say atoms A, we have been given the atoms A, B, as well as what? As well as C. Then we say they have those electrons. Okay, so maybe before we go to this, at a secondary level, there is a manner in which you can write the electronic configuration of any element that you are given. For example, if you go to the first if you go to group 1, you go and pick sodium. This is sodium. It's 23 the mass number, and 11 the atomic number. If you want to write the electronic configuration of sodium, is that you can say it's 2 what? 2 in the first shell. The second shell can give it 8, and what's the remainder? 1. That's the electronic configuration. Yeah, but of course when you go to a higher level, you're going to be using s, p, d, f orbitals. Okay, but at this level we're just going to talk about this part. Alright, so now we are given elements that are replaced using variables a, b, and c. We have been told to say the electrons that a have is what is 8, c has what 17, and sorry, b has 17, then c has what 20. So now the question is saying, using the letters, the question A says, using the letters, construct a chemical formula of a compound formed between atoms A and C. So here we are basically talking about the relationship between A and what? A and C. So now the first thing that you can, the wise thing that you can do in this case is that write the electronic configuration first for you to know the number of electrons that is that particular element is ready to gain or to lose, or let's say to share. So for A we have 8, so meaning we can put 2, that's 2 comma what, comma 8, sorry, 2 comma 6, I mean. That gives us a total of what? A total of 8. Remember to say, we say the second shell can accommodate 8, but in this case we only have 2, hence we're going to give, in this case we only have 6, so meaning we're going to give it the 6 that was the remainder after filling up the first shell. Then you go to C. C has 20, meaning it's going to be something like 2 in the first shell, 8 in the second shell. So this is already a 10, meaning remaining with 10 again. So meaning, because we know to say in the third shell we can give a maximum of 18 electrons, but in this case we don't have that 18, so we can just give the third shell an 8 as well. Okay, then the fourth shell can give it what, the remainder, which is what, which is a 2. So when you look at this, when you look at element A, it has shown to say we have 2 shells, and these two shells, us counting this number of shells represents the period in which element A is in. Then us looking at the number of electrons that we have in the outermost shell, the outermost energy level, which is a 6, which gives us what, the group that is in. So meaning this one has how many shells? 1, 2, 3, 4. So meaning this one is in period what? Period 4. This one is in period what? Period 2, because of the number of shells. So when you're finding the number of periods, just count the number of shells that you have. When you want to find the group, just look at the valence electrons that you have. So for A, it has 6, meaning it's in group 6, and group 6 elements are called something like chalcogen. Group 6 elements, we say they are called chalcogens. Then when we go to group it has 2 in the outermost energy level, that's the fourth shell, meaning it's in group 2, and those are alkali earth metals. Yeah, so you are bonding these two, and if you look at if you have understood properly the periodic table topic, it'll be very easy for you to answer this question, because you're able to know which one is ready to gain and which one is ready to lose. So when you look at element C, it has 2, so it can easily lose these 2 than it can gain an 8, a 6 to make 8. Then for A, instead of losing the 6, it would rather gain 2 to have a what, a 4 outermost energy level. So what we are going to say in this case is that A has a valence of what, 2. We're talking about it needs 2 to have a what, a 4 outermost energy level. It needs 2 electrons. Then for C, it's in group 2 to be 2 as well. It's ready to lose that 2 to give it what, to that one. So meaning we can cancel out those 2 that we have right there, meaning because the question is asking that to use using the letters, we should construct a chemical formula of a compound formed between atoms of elements A and C. So this is what we are going to have. Right, so when you go to question B says elements B and C can react to form a compound. So now we are picking B and what? B and C, these two. They can react to form a compound. Then the first question says, name the type of bond that is formed. So very, very important once again. Remember to say for C, we already wrote is something like 2, the electronic configuration 2, 8, 8. We say 2, we have 8 there, and we have a what? We have a 2. Then for B, we are going to have, we have 17 there, meaning we have what? 2 comma what? Comma 8. We have remainder of what? Remainder of 7. So this has 3 shells, meaning it's in period what? Period 3. This has 4 is C period 4. The 7, the number of electrons that are in the outer atmosphere, which is 7, gives us the group it reaches in, which means it's in group what? Group 7. Those are halogens. So meaning this one needs 1 to have a full outer atmosphere energy level, but this one is ready to lose a 2. Now there, it might seem like it's not making sense. It might seem like maybe we're going to have a remainder of 1 here when this one gives to this one, but here's where it's going to make sense. B has a valence of 1, or maybe we should write it like this. We put our C this side and we put our B the other side. We have said C has a valence of 2 and B has a valence of 1 because it needs 1 to have full outer atmosphere energy level. And what will happen? These are going to exchange. This one is going to go to B and the one is going to go to what? To C. So what you're going to have in the end is what? C. Okay. What you're going to have is C what? C1, B2. So now what you have here is that you can just ignore the 1. Just say this is C what? CB2. Okay, so meaning these 2 electrons, one is going to go, because meaning here you have how many B's? You have 2 B's. One is going to go to this B, the other one is going to go to what? To another B. In the end we have what? 2 B's in this case. So now when you look at this, when you look at the ones that are in group 7, these are non-metals. Okay, these are non-metals, and when you look at this is a metal, and the bond that is formed between non-metals and metals is called what? An ionic bond. An ionic bond. So we have answered that question. So doing this work was very necessary for us to know what type of bond it forms. So when in case maybe we were to encounter a situation where these two are sharing electrons, that could have been what? A covalent bond. If it was a metal and a metal, that could have been what? A metallic bond. So now we have answered that question. So meaning here we can say, okay, so here we formed something like AC. Here we are going to say it's a what? Ionic bond. Ionic bond. That's the bond that is formed between those two. Then we say state one physical property of this compound. So the physical property of this compound is that we're just talking about the properties of ionic bonds. Ionic bonds form, we can say they form what? They form crystals. For example, if you pick sodium, a metal, you pick a chlorine, which is a non-metal, you're going to get sodium chloride. That is common salt. Makes sense from that point of view. You can also say they conduct electricity when in molten. Electricity conductivity when in what? When dissolved in water, in other ways. Okay, there are a lot of properties that you can give, such as the level of boiling point and the melting point, so on and so forth. Then question C is asking us to draw the electronic structure of the product formed when atoms of A do what? Combine. That's what we are looking for right there. So atoms of A do what? Combine. We're looking for what? The electronic structure. So we need to say our A was 2, what? 6. So meaning this one needs to have a what? A 4 atmosphere energy level. Meaning we are picking another A again. 2 like that. So meaning these two are going to do what? They have to come together, meaning they are going to share electrons. This one needs 2 and this one needs 2. So what you're going to have in the end is something like this. And when you look at this, A is a non-metal. Okay, so this one needs 2 and this one needs 2, meaning this one is going to share 2 with this one, and the other one is also going to share 2 with that one, meaning what you're going to have on the middle is that you're going to have, I'll say 1, 2, okay, another 2 from the other side. So you can say this is our what? Okay, this is our A and this is another A. So remember to say our A had what? Had 6. Our A had 6, and this A shared 2, meaning you have a remainder of what? Remainder of 4. So you can put a 2 right there like that, another 2 right here, this one all the same as well, 2 right here, 2 right here to make the what? The 4. So if you count this has what? This was 8 and that one has 8 as well, meaning you have what? A 4 outermost energy level. So when you look, the last question is asking us to find what? To find the industrial use of B. So when you go to the nature of B. Looking at what we have said B is something like this. We have what? 2 comma what? Comma 8. This is our B. 2 comma 8 comma what? Comma 7. So now what we have here, we said it shows us the group in which the B belongs, and this belongs to group what? Group 7. And this belongs to group what? Group 7. And we go to group 7, the one that has this number of electrons is what? Is chlorine. So we are being asked to say what is the use of chlorine in this case. So we can talk about what chlorine works as a disinfectant. Okay, disinfectant, meaning we treat drinking water that is found in pools, swimming pools, this and that. So that's how you go about answering that question, and applying the same rules that we have used here, you can be able to answer any question on chemical bonding. It's very easy. Yeah, so that's how you go about answering that question, and that's all for this video. Thank you.